Hello, my name is Isaiah Speight, and I'm a fifth year graduate student at Vanderbilt University in the Hanusa Research Group. And this presentation is to discuss some work that we've done in solid state Grignard chemistry. So, the Grignard reagent is typically derived from chlorinated, brominated, and iodinated organohalides. And we typically don't look at carbon fluorine bonds as things that we can activate to generate Grignards. But there are some very sparse examples of how to do so. Henry Gilman first reported that you can use a very unique magnesium copper alloy, but the reaction takes 18 months on standing. You can also use Ricci magnesium to get a more robust reaction. And also, in some work that Crabtree reported, you can use magnesium anthracene, which is a bit of a out there form of magnesium, which is a little bit more difficult than people expect to synthesize and then utilize. But we thought that we could use mechanochemistry to overcome the strength of the carbon fluorine bond and make Grignards from fluorinated species. So, mechanochemistry, for those who don't know, is defined as a chemical reaction that is induced by the direct absorption of mechanical energy. And those reactions can be done either solvent free or solvent assisted. And the mechanochemical method has been employed in the formation of Grignards before. In some work reported by Harrowfield and co-workers, you can use aryl halides and treat them with magnesium by ball milling along with a electrophile to make the appropriate Grignard product. So we thought that we would take their work and expand upon it by doing some work with fluorinated compounds. In some initial screening with bromobenzene, we saw that we could do a homocoupling of the subsequent Grignard to make biphenyl in 73% yield. We also saw that if we took 2-fluoronaphthalene and milled it to make the appropriate Grignard and treat it with water, we would arrive at naphthalene at roughly 80% yield. So from there, we did some comparison studies and saw that regardless of the position on naphthalene, whether it be in the 1 or 2 position, or the halide in question, we see roughly the same yields across the board. And we attribute that to the charge buildup at the alpha carbon of the Grignard that's generated. Regardless of what the halide is, that charge at the alpha carbon, whether it be at the 1 or the 2 position, is very similar, as you can see in the diagram shown on the right-hand side of the poster. So with that, we come to the conclusion that we can use mechanochemistry to consistently activate the carbon-fluorine bond. We remove the need for exotic magnesium sources and extremely long reaction times. And we see that the reactivity of the Grignard that's generated is similar whether you use a brominated substrate or a fluorinated substrate. And with that, I'd like to thank the funding sources that made this project possible, and I'd like to thank you for taking the time to listen to this presentation, and I will be more than willing to answer any questions if you reach out to me. Thank you.